Okay, good morning, everybody. Thank you for joining us. I guess there'll be some folk still logging on, but you are hopefully going to see on your screens a presentation for today's Insights Online with NMIS, with the topic of Manufacturing Scotland's Electric Future. I have on the call with me today two of my colleagues, and we'll start off by doing some quick introductions. So my name is Gladys Bengalia. I am the strategic lead for our net zero electrification theme here at NMIS. And my role is essentially to bring together industry, academia, our policymakers, our government in achieving our net zero targets specific to manufacturing, supply chain development and capability development in this area. I'll pass over to Dan, and Dan will also give an introduction to himself.
Morning all, I'm Dan Cutting. I'm Business Development Manager for DER-IC Scotland. My role covers a number of university partners, which I'll go through later on in my presentation. My role is to work with industry to understand how the DER-IC network can support the electrification of multiple sectors, and specifically how we can support the supply chain and growing to achieve that, so that the UK maintains a role in supplying into the future electrification platforms that are being developed here and around the world. That's all from me. I'll hand over to Jill.
Hi, good morning. I'm Dr. Jill Scanlon. I'm a senior manufacturing engineer at NMIS, and within NMIS, I'm the lead researcher for the FEMM Hub, which is looking at the design and manufacture of high-value, high-integrity electrical machines. And I'll go into a little bit of the detail of some of the work that we're doing within FEMM Hub, and I'll talk a little bit about the sustainability element of that later on in the programme as well. Gladys, back to you.
Thank you. So now that we've done our introductions, hopefully we can flow through this presentation, and I'll start off with some housekeeping. So this webinar is being recorded and will be made available on our YouTube channel. And because of the recording, your microphones and webcams will all be switched off during the session to avoid any background noise. You can type your questions throughout the session into the chat tool. Time will be allocated at the end for us all to answer your questions. We will keep an eye on your questions throughout the session. If there are any that we feel are worth addressing straight away for the clarity of the session, we will do so, of course. Please feel free to use the hashtag NMIS Insights if you do have any questions that you want to post on Twitter. And also there will be a survey shared with yourselves following the session. We would much appreciate if you shared any feedback that you have on the session. So what is the National Manufacturing Institute Scotland? The National Manufacturing Institute Scotland, NMIS, is a group of industry-led manufacturing, research and development facilities where we bring together research, industry and the public sector to transform skills, productivity and innovation with the objective of attracting investment and ensuring that Scotland is a global leader in advanced manufacturing. So the objectives that NMIS has, NMIS will increase productivity by reducing barriers to innovation. It will stimulate investment and increase manufacturing competitiveness, catalyse job creation and strengthen supply chain links, inspire and attract talent and equip current and future workforces with the skills that they and their businesses need, and work with manufacturing businesses of all sizes across multiple sectors to provide benefits for the whole of Scotland. So NMIS is a Scottish team effort. It is operated by the University of Strathclyde and it is supported by the Scottish Government, Scottish Enterprise, Highlands and Islands Enterprise, the High Value Manufacturing Catapult, Skills Development Scotland, Renfrewshire Council, the Scottish Funding Council and South of Scotland Enterprise. So to explain a little about the NMIS Group. So the NMIS Group is a combination of core NMIS capability, specialist technology centres and an active network of partners in the manufacturing community. So NMIS comprises of multiple different elements, which you can see in this schematic here. The yellow regions are specialist centres that are open now. So we have the Advanced Forming Research Centre and the Lightweight Manufacturing Centre. So the Advanced Forming Research Centre has actually been delivering programmes and research in collaboration with our industry partners for over 10 years. It has its own dedicated facility out in Shannon, and has been specialised historically in forging and forming processes. We are now, with the birth of NMIS, creating many more priorities and research strands. And with that came a new centre of the Lightweight Manufacturing Centre, opened in 2019. And the Lightweight Manufacturing Centre specialises in non-metallics, sustainable manufacture in these programmes, and is located at Westway in Renfrew. We also have with the purple zones our outreach programme. So the outreach programme via the NMIS network operates with industry partners, academic institutions, public sector bodies to fully exploit the opportunities for manufacturing within Scotland. And this is coupled with a workshop space being acquired in order to accelerate the development and the commencement of programmes until our NMIS HQ is open. And that is due to be in 2022. And the NMIS headquarters, which is being built out near Glasgow Airport, will comprise our digital factory, our collaboration hub, and our manufacturing skills academy. So hopefully that gives you a bit of an overview of what NMIS is and how we are working towards developing manufacturing within Scotland. Now to move on to the contents. So I will begin with setting the scene for the drives for manufacturing, sustainable manufacturing, the economic opportunities that are aligned with sustainable manufacturing, the challenges that we are hearing from our industry partners at present, and the way that NMIS is approaching these challenges. Then I'll hand over to Dan, who will talk about the Driving the Electric Revolution industrialisation centres, the challenge and the Scottish partners that we have within DER-IC. And then hand back over to Jill as well to talk about the Future Electrical Machines Manufacturing Hub, the technology developments, the supply chain development that is ongoing there. And we'll then end with some questions and answers. So in terms of manufacturing for sustainability, we are all aware that we have net zero 2045 and 2050 targets in Scotland and the UK respectively. And in order to achieve these targets, we must establish and develop globally competitive manufacturing capabilities and resilient UK supply chains, specific here in the case for electrification technologies. This also encompasses the reduction of our dependency on carbon-intensive manufacturing processes and developing novel technologies to support the transition. And we are very much aligned and supportive of our governmental targets. So we've got the 2050 net zero target from the UK government, and we've got the 2045 target from the Scottish government. We'll all know that COP26 is coming up as well, and COP26 is really focused again on securing that global net zero by mid-century and gaining increasing awareness across the world in terms of that challenge. Looking now at the economic opportunities aligned primarily with the programmes that NMIS is operating alongside and is leading. We have our Future Electrical Machines Manufacturing Hub. This was commenced in 2019, and the drivers for this were really the ability for the UK supply chain to accelerate, to support, to really develop the capabilities in terms of manufacturing for electrical machines. And the markets there that you see, there's a more electric aircraft market predicted to be at 11 billion by 2025. Global offshore wind was predicted to grow sixfold by 2030, and the automotive electric motors estimated at 36 billion by 2024. So a huge market there and a huge opportunity. In line with our Scottish enterprise within Scotland, they have a national programme on zero emissions heavy duty vehicles, and this is really underpinned by the investment in electric vehicles globally being planned to reach 300 billion over the next 5 to 10 years. So again, a huge market there. I'll briefly touch on the Driving the Electric Revolution Challenge, which Dan will go into in much more detail. But again, this is a UK programme, a UK challenge where we are supporting the UK's push towards a net zero carbon economy, with the £80 billion gross domestic product by 2050 being estimated. Likewise, we are in alignment with ATI's Fly Zero programme. This is a programme that has been launched just this year, where the ATI are looking to realise zero carbon emission travel by 2030. Now, moving on to the industry challenges and those that we're working on with our industry partners at present. Number one is preservation. So clearly the last 18 months or so have given us unprecedented disruption within, for example, the aerospace sector. And it's really about how we ensure that our economy and our manufacturing sector can recover and can grow following this disruption. But we are not just looking at the aerospace sector. We are understanding that as a Scottish manufacturing sector, we have a multitude of expertise that can be applied across sectors, and it is really about that revolution in power electronics, machines and drives across these many sectors to realise the design, manufacture and integration opportunities for increased power density and efficiency, reduction of weight, reduction of cost to manufacture. And reduce time to market. Of course, that is important, particularly in the case of electrification, where time is of the essence. We have a lot of very tight time constraints now in delivering targets and ensuring that manufacturing can achieve those targets to the best of their ability. Reshoring and sometimes to the creation. So reshoring and the creation of supply chains within the UK to exploit these opportunities in a sustainable manner. So sustainable manufacturing requires us to really consider the circular economy from day one. So integrating that into the design of any component of any system to really think this needs to be able to operate. It also needs to be able to perhaps have a second life or to be recycled. And it's really about that consideration at the beginning of that design process. And like I mentioned, for us within Scotland, it's the sort of heavy duty vehicles that we're focusing on. So that's aligned with our Scottish Enterprise National Programme, which focuses on off-road, on-road, rail, aerospace and marine. So looking at a sector agnostic approach, again, the focus is increasing Scottish content and doing so in the best manner possible. So really understanding the skills that we have within Scotland and how they can be translated across sectors that companies may not necessarily traditionally have operated within, creating the right messaging across that so that companies feel comfortable to exploit opportunities, and NMIS can support them in doing so, de-risking that innovation, de-risking the requirement to upscale that manufacturing capability. And that's really done by focusing on components or task-specific manufacturing opportunities so that we do not alienate any organisations, any of our stakeholders within that process, and making sure that we can all work together to achieve that resilient supply chain. So just lastly from myself, looking at the NMIS vision and the approach, for those of you that know the Advanced Farming Research Centre, you will maybe understand how we've worked. We are working no differently now in terms of electrification. And that is looking at operational performance and the impact that manufacturability and the lifing of materials has on that operational performance, reducing the time to market, production through optimised design and manufacture, revolutionising the design traditionally of components within power electronics, machines and drives, with a focus on sustainable manufacture and resource efficiency, and all underpinned by this want to shape and to grow industrial supply chains and innovation across sectors within Scotland and across the UK. So that's been a little introduction to the electrification challenges within NMIS and how we are approaching them. I will now hand over to Dan, who will speak a little bit about the driving the electric revolution and the industrialisation centres. Thank you, Dan.
Thanks very much for the introduction, Gladys. If you just go to the next slide, please.
Sure.
So this morning I'm just giving a brief overview of DER-IC Scotland, what that means, and what we're doing in collaboration with NMIS to achieve the goals. So if you just go to the next slide, please, Alice. So in terms of DER, it was launched by UK Research and Innovation as part of the Industrial Strategy Challenge Fund last year. It's now run solely by the UKRI. And what that looked like was an £80 million pot of funding, of which just under 30 million was invested into the academic network facilities in the UK to help scale up some of the equipment capability to support the UK manufacturing process for power electronics machines and drives. I'll come back on to what I mean by that in a second. The 10-year vision for the centres is to make the UK globally recognised as the centre of excellence for power electronics machines and drives manufacturing processes. So the mission then is to provide a UK network of open access facilities for both our UK and global partners to grow world-class design, manufacturing, test and validation capabilities. So what that looks like on the next slide, please, is a network of partners across the UK who are in 4 clusters, regional clusters, one in Scotland, one in the northeast of England, one in the Midlands, and then the southwest and Wales. The idea is building on an existing £300 million worth of equipment and academic capability across all of these facilities, bringing them together, and then the additional investment of £30 million to kind of fill key gaps and rapidly scale up the capabilities of the centres. There is recognised PEMD expertise across all these centres in a number of different areas, whether that's at semiconductor level through the compound semiconductor catapult in Wales, or the drives, for example, in Edinburgh's power conversion group. So essentially what the DER challenge aimed to do was leverage significant regional expertise and then allow us to work with industry to leverage national devolved funding to carry out R&D programs, and specifically with a long-term view of having that impact on manufacturing processes and growing the supply chain in the UK. I think we're going to the next slide now, please. So Gladys covered a little bit of this, but the challenge really is pretty well known now and across all sectors that we cover, of which there are 10, which is pretty much anything you can imagine, to be honest. There are a number of specific targets. So from an automotive perspective, looking to be zero carbon by 2035. There's a number of regulations coming in on air travel and a lot of focus on reducing the emissions there. And likewise across all the different sectors. What I should say is here in Scotland, we're focused on high power, high integrity and systems. So for us, it's aerospace, rail, marine, heavy duty vehicles. So that's off highway, truck and bus, and the energy and industrial sectors. But wider in other sectors, we cover micromobility, automotive, and robotics as well. Next slide, please. So what do I mean by power electronics machines and drives? So I'm kind of aware that the NMIS network might not be very close to this. So power electronics are semiconductors which enable switching of electricity, and the main purpose of power electronics is to change one form of electricity into another. So what that looks like, the most common one, I suppose, that people might not realise is power electronics are around us every day. So power electronics are the technologies that convert AC to DC. So when you plug your phone into the wall, you're converting AC current to DC to charge your phone. So power electronics at a basic level is there to change the type of electricity you're using. Electrical machines are about changing electrical energy into mechanical energy. So what we're looking to do here is find ways of changing from platforms that are traditionally powered by combustion engines, burning fossil fuels, and turning mechanical machines and turning that into electrical machines, where we're taking either a battery source or a hydrogen fuel cell source and converting that electrical energy into mechanical energy. Obviously, these have existed for many years, but obviously more sectors are looking to adopt them and use that to reduce the emissions across the board. And then drives are kind of embedding intelligent control into machines and power electronics, so that we have a controlled system which allows you to look after thermal management and have a bit more control over that as well. So what do we mean in terms of the manufacturing supply chain? So DER is interested in everything from materials processing right through the life cycle to reuse and recycling. That'll tie in a little bit into what Jill mentioned later on. And as I mentioned, there's 10 sectors that we're currently covering. Next slide, please. So in Scotland, we are supported by 4 universities. University of Strathclyde, which hosts DER-IC Scotland through the PNDC, the University of Glasgow, University of St Andrews, and University of Edinburgh. Each university carries a slightly different focus. So the University of Strathclyde, energy systems primarily, is what drew the centre to being hosted by Strathclyde. A lot of experience in developing electrical systems through modelling and demonstration at the likes of the PNDC facility, and then a lot of work in terms of looking at power electronics, drives, and electrical controls. The University of Glasgow, specifically their James Watt Application Centre, are focused on power semiconductor devices, primarily GaN, gallium nitride, and they're a clean room facility at the University of Strathclyde, where they have a lot of equipment that are focused on manufacturing processes and semiconductors. The University of St Andrews are primarily hydrogen and battery experts. And one thing, taking the systems approach in Scotland that we were cognizant of, I suppose, was that the development of drivetrains in electric vehicles or in aircraft, it's going to be dependent on whatever energy vector you choose. So, if you want to power your system with batteries, you're going to have an impact on the adjacent power electronics and machines. Likewise, if you use a hybrid approach with battery and fuel cell, we need that expertise and we need to tie this in. So in the longer term, we need to understand how the impacts and is impacted by things like battery developments or the hydrogen economy. And finally, the University of Edinburgh is a power conversion group. So they develop drives for the energy sector and heavy duty sectors as well. And the group there are really focused on developing novel generator designs, converters, and look at things like the DC systems for HVDC transmission from the wind energy fields we have out in the North Sea. So across these 4 universities, we can kind of filter the involved facilities into 3 groups: the manufacturing group, which is where NMIS comes in, Future Electrical Machines Manufacturing Hub, and then electrical systems and the test facilities we have at the PNDC in Cumbernauld and the TIC in Glasgow. So there's a lot of partners involved, and if we just jump on to the next slide, I can explain a little bit about what they all contribute. So as I mentioned, we're focused on high power, high integrity sectors. So that's heavy good vehicles, rail, marine, aerospace, in addition to energy and industrial sectors. The way that we look at things when we're kind of taking a view of our capability is that we're here to support from using the traditional academic expertise, first principles, right through to commercialization. The intent being that we can work with the likes of OEMs or tier ones to understand requirements and how that flows down to their collaborators and their supply chains. So, through the likes of NMIS, we're interested in the early stage requirements gathering, design, and design for manufacture. And then, we go around the wheel. We've got a view of devices, so taking that platform level requirements down to how does that impact device development and also manufacturing processes. So things like the cost of devices will impact on what choice platform owners are likely to make in the future. So then we have the device capability, then we go into subsystem capability. So that might be a machine or a drive, then into powertrains. So what does that look like as part of a bus or a truck or a plane or a train? And then finally platforms. So that's when, it's part of the full system. So, the partners cover many different aspects of all these different areas we're focused on. So taking an example, the PNDC, which I'm sitting in just for the first time, that's quite exciting, is going to be developing capability to test powertrains in the future. So in 2022, they'll have a new part of the facility open, which will allow us to test powertrains using 1 megawatt scale dynamometers. And then after that, we'll be able to take things to Locate, which is going to be based at NSIP, who have recently joined the DER, and allow us to test full platforms. So once you can sit in it and drive it in, we'll be able to use the capabilities there to replace essentially what was traditionally off-road testing. So through the kind of capability that the NMIS team are going to share, we're able to do that in an early stage work, and then take that through with the partner capabilities and do the test and validation of the equipment as well. So the intent of DER is to provide a joined up approach in terms of developing power electronics machines and drives technologies and the relevant supply chains. And the intent is just to make sure really fundamentally that the UK is maintaining a strong presence and delivering these technologies for the future, so that we don't get left behind, and that we're still, a major contributor to both technology and supply in the future. So I think with that, I'll hand over to Jill to talk about FEMM Hub. Thanks.
Thanks, Dan. So yeah, I'm going to speak about the FEMM Hub, which is a project that I'm leading within the NMIS. So its full title is the Future Electrical Machines Manufacturing Hub. It's a 7-year EPSRC project with partners of universities of Strathclyde, Sheffield and Newcastle. We also have NMIS and the AMRC in Sheffield as partners for the more manufacturing side of the project. So the FEMM Hub is looking to address key manufacturing challenges for future machines, and in that we're looking at high integrity, high value machines. So we're really looking at low volume production, not really looking at mass market. We're looking to deliver academic and industrial advances through the development and application of some of the novel manufacturing processes that are being developed at the moment. And you can see along the bottom of the slide there, we've got quite an extensive industrial advisory board. We've got everybody from Airbus and Rolls-Royce through to smaller companies such as Tanlin, and also the Catapult Network and EPSRC are on there as well to help direct the research to ensure that we can get as much applicability as possible. We are looking to deliver world-class manufacturing research with the aim of really capturing value within a UK-based electrical machine supply chain. So this feeds into what Dan was saying as well about the purposes of DER. FEMM Hub is really just one aspect of that, which will be engaging with DER to bring industrial productivity back to the UK and really bring the high value manufacturing of these high value components and machines to the UK. Gladys, next slide, please. So the FEMM Hub, as I said, it's a 7-year project and it's split up into what we term grand challenges. So the first grand challenge is really looking around the manufacturing-led innovation. So one of the key aims of the FEMM Hub is to really bring the manufacturing opportunities and considerations right to the initial design stages of the electrical machines, to ensure that we can sort of make things a little bit more efficient and quicker development, but also to open up the design opportunities for these machines by implementing new manufacturing processes that weren't available 10, 20, 30 years ago, to really allow for new designs and new combinations of components. The second grand challenge is looking at process innovation and simulation. So trying to understand how we can define the processes better, how we can have better control over them to really get high performance and ultimate control of everything that gets manufactured. So that will be through maybe the development of new manufacturing and assembly techniques. It's also through in-process tracking and traceability, so that we can perhaps ensure that we get zero defect components manufactured, and we can detect any issues with the manufacture in real time, as opposed to waiting until things are assembled and at the end of the line process testing. The thing that I'm going to talk about in a little bit more detail today is Grand Challenge 2.5. So this is the newest of the Grand Challenges. It only we only kicked off in January, but it really came about through discussions with partners and also looking at the way that electrical machine research was going. And we felt it was hugely important to have this grand challenge, which is looking at sustainable manufacturing and the circular economy for electrical machines. Next slide, please. So for those of you that are not aware or aren't too familiar with electrical machines, this is a sort of breakdown of a permanent magnet electrical machine. So the way that the components are typically split up is we split them into active and non-active components. So the active components are the things that add to the electromagnetic performance of the machine. So things like the copper windings, electrical steel laminations, and permanent magnets. And then the non-active components are basically everything else that add mechanical structure to the machine and also keep the machine clean from the external environment. So things like the internal shaft, the outer casings, and the end caps. Next slide, please. So electrical machines are a clean way of generating electricity, a clean way of generating power. However, the manufacture of these machines are not as green as they could be. They're not optimized in terms of some of the issues that we see with it. So that the copper windings are coils which are drawn, they're then wrapped in insulation, they're wound round the central stator and they're compressed in place. And then to essentially help with the compression and also to help with the thermal conductivity, they're often dipped in resins, so they're fully encapsulated in a resin. This helps with the performance and it helps with the in-life optimized service. However, when you come to the end-of-life process, and the resins really are extremely difficult to remove, and they cause a lot of issues at the end of life. The steel laminations are extremely thin sheets of electrical steel, and we're talking maybe between 0.2 and 0.4 of a millimeter in thickness. Because of the thinness of the sheets, they typically go through multiple sheet rolling operations. Once they're at the final thickness, the components are then stamped into their required geometry. But with that stamping operation, there's usually a high amount of wastage of the materials. And then everything, when it's put in the assembly, everything's glued together, which again doesn't help with the end-of-life processing of these materials. The permanent magnets in the machine, obviously with magnets, there's a lot of mining operation in there. There's also multiple processing steps, so all that leads to a high climate cost. And then typically they're glued or they're stuck in, or they're wrapped in place, which again, the end-of-life processing is made difficult through that. For the non-active components, the shaft, the casing, and the end caps, they all really have the same issues associated with them. So where the active components have had a lot of focus in terms of research in the last 10, 20 years, the non-active components really haven't had the same level of research done with them. So quite often they're maybe not fully optimized in their design. And typically the non-active components account for about half the weight of the electrical machine. So if we can get optimized designs where we're really focusing on the lightweighting, we can get a lot of weight out of these machines. And if we're looking at something like automotive or aerospace applications where you're having to carry that electrical machine on all of your journeys, then every kilogram that we can take out the machine is going to be beneficial. These components as well, when things are assembled, they're quite often put together in a way which again is not really helpful for the end of life processing, so they can be welded together or stuck together. And these components really are designed for use. They're not really designed with the through life in mind. They're not really designed for repair or disassembly. So we're trying to get those design aspects again right into the initial development of these components in these machines. Next slide, please. So in terms of the technology development that we're trying to do, there is obviously with the grand challenges that I showed right at the start, there's lots of different design issues that are trying to be resolved within the FEMM hub in general. But what we're trying to do is, while we're doing all the technical design work and the challenges of increasing the power density of these machines, we're trying to put the circular economy of the machines and the sustainability of them right at the forefront and make it an integral part of the conversation. So within one of the work packages that I'm leading, we're looking at developing a methodology which integrates the design and the manufacturing of these machines so that they're essentially acting as two modules which talk to each other. So you're not just having the linear approach where you design a component and then it goes and you try to manufacture it. But like I said earlier, we're trying to take the aspects of the manufacturing which can actually get us benefits that previously we couldn't get, so that you can then feed that back into the design and you have this iteration. So at the moment, we have the design constraints and the manufacturing constraints locked in, and we're developing work on just those two. But really the long-term goal is that we have multiple modules which can all interact with each other so that you can actually get a fully optimized solution at the end of the work that you're doing. So these can involve things like life cycle assessment of the components in the machine, also things like process modeling. So at AFRC and LMC, we've got large teams of process modelers, and the idea behind that is if we can do a lot of things computationally, then we don't have to waste materials and waste energy actually doing physical trials. If we have process models that we can trust, we can reduce consumption and we can also speed up the process as well. Some other things that we're looking at of implementing as modules, things like cost modeling activities, the carbon cost of different manufacturing routes, and also things like design for secondary applications. So if we know that when the electrical machines come out of their primary application, they're going to get reused in a secondary application. If we are aware of what the secondary application might be, can we then make design changes which just makes that transition easier so that the materials aren't going to landfill and they're not having to go back to the recycling stage either. They can get reused or remanufactured for a second life. Next slide, please. So that was just a very brief overview of some of the technology development we're doing, but with Grand Challenge 2.5 and the FEMM Hub in general, what we're also trying to do is help develop a supply chain. So we've been doing several activities in the last few months which are looking at developing the understanding of what is currently going on in the UK supply chain. So we've got an industrial survey which is live at the moment, which is trying to understand the circular economy and sort of remanufacturing, reuse activities which are taking place in the electrical machine supply chain. And we'd welcome anybody to please submit to that industrial survey if this is an area that you're working in. What we're trying to do with that is really understand what supply chain we have at the moment to be able to identify gaps so that we can help through NMIS, through DER and through the FEMM Hub, how we can help actually develop that supply chain into something that's fit for purpose for the future of the reuse, the recycling of these electrical machines. We've also recently produced a review of the circular economy research, specifically for electrical machines, and that paper is available online. If you have any issues accessing it for whatever reason, feel free just to email me and I can send you a copy of that paper. But that really sums up sort of the work that's going on currently for circular economy of electrical motors, and also looking at how we can potentially use industry 4.0 technologies to help develop this work and really optimize what we're going to be doing in future. As Dan mentioned, the DER industrial centres, 4 of them are across the UK. I personally are engaging quite a lot with the Scotland Centre, and it's really about joining up networks, joining up contacts and joining up all the work that's going on so that we can get something that's more than the sum of its parts and we can really get a momentum behind this area. As well as the DER centres, we're also looking out with the electrical machine world. So there's a circular economy hub, which was launched just earlier this year, which is based at University of Exeter. So the circular economy hub, they don't have anything specific on manufacturing or electrical machines, but they do have a lot of contacts within the circular economy research area and also within different sectors where there is good practice already going on. So what we're trying to do is engage with people outside the electrical machines world so that we can understand the best practice and we can implement that within the electrical machine space, which goes back to what Gladys was mentioning earlier about trying to reduce the lead times for the development of this work, so that we can get things moving as quickly as possible. And all this work with the supply chain development is really looking for us to be able to develop guidelines, offer support to the supply chain to really support their decisions on what sort of end-of-life strategies, what sort of circular economy practices are advantageous for their business, for their application, and how we can actually help the supply chain implement that as quickly and as efficiently as possible. And I think that's my last slide, Gladys. Yes.
It is. Thank you very much, Joe. Just start back up my video. So thank you very much to Dan and Joel as well for the presentations today. We are all still here and willing and hopeful of answering any questions that you might have. Let me just check in the chat if there is anything. Please do feel free to pop any comments, any introductions to yourselves, how this might align with your businesses, your organisations, and even if not today, we are happy to continue the conversation. Please feel free to link up with us on LinkedIn or through the NMIS or the DER-IC Scotland initiatives, through our contact details there. I can't see any questions at the moment.
I'll start with a question, Gladys, for both yourself
sure.
and Dan. So obviously within NMIS, we've got an electrification strategy, and DER Industrial Centre Scotland is obviously looking at developing supply chains in Scotland. So if there are companies out there that want to get engaged and feel that they've got something to contribute to this, what would be the easiest way for them to engage with NMIS and DER?
So initially just reach out. An introduction to yourselves. Usually we would start by an introductory call as well to understand the organisation, the objectives of the organisation, and really through what myself and Dan have presented today, it's a team effort. So it's really then about understanding which parts of the DER-IC Scotland network can support best. How do we bring all these elements together to achieve the full potential of an opportunity? And that's what we're here to do at Strathclyde. So we'll work together to really find a way to de-risk and to develop any capabilities and any opportunities that you may see within your organisation. Dan, I don't know if there's anything you'd like to add to that.
Yeah, only that when the DER industrialisation centres were established, one of the key things from UKRI is that they're looking for us to be a front door to all the capability of the partners involved in DER industrialisation centres. So for me, my role, as a first contact, I suppose, when speaking to industrial partners, just to understand, what area they work in, what their key challenges are, and then I'll help go and find the right person essentially and refer them on. So for example, if we're talking about a manufacturing challenge, then I would probably call both of you two in the first instance. But if it was something around testing, it might call somebody else, whether that's P&DC. And then I should say that there's the wider network gives us the additional capability. So if there's any areas that during an NMIS project that the team feels there's a gap, then the DER network is there to help them leverage the existing expertise, because there's a lot of equipment and there's a lot of people in the UK, and the key thing, especially just now when there are so many projects going on, is just to maximise the use of what's already there, rather than trying to, suppose, set up multiple equivalent hubs all over the UK.
Absolutely, and I think to add that because NMIS is in its growth stages, we're making very crucial decisions with regards to capability investments, and that is really driven by what we're hearing from our industry partners. So that's why it's all the more important to have these discussions. We've had an invite there from Alan at Tanlin. It's good to see you on Alan. We've had email exchanges before, but this is the sort of thing where we're finding that as we're going through the journey, we're really starting to link up with a lot of our partners across Scotland, and now that we can get out and about again, we can come and do site visits. We can really understand what your organisations are working towards, and work on a collaborative framework to achieve that together. So we're more than
one of the
happy to
things, I suppose for me, one of the things that I covered was the sectors, and a big thing for DER is enabling a cross-sector approach. So there's all these different targets now, and different companies are all working towards the same end goal, really, of achieving zero emissions, whether it's small vehicles or large. And a big part of DER is trying to bring those people together, because at the end of the day, they'll likely be using the same supply chains, potentially using the same technical solutions. So, being part of the network and just, letting us know, what you're working on, what you're interested in, is really useful, because, part of our kind of role is to help make those links between industry. So, sometimes you're not looking for an academic partner, you're just looking for some help in finding the right person to supply, whether it's a very specific part of the manufacturing process that Jill was describing, or whether it's a specific company supplying a full solution. Part of our role is to help with that networking. So for me, it's all about joining everyone up. I guess a question then for the NMIS guys, sector-wise, you are fairly sector agnostic, aren't you?
We are sector agnostic. Like Jill said, we, in terms of the FEMM Hub and generally because of the Scottish Drive, we are tending to focus more on the low volumes or the high value, high integrity side of things, very much driven as well by Scottish Enterprise with the 5 sectors in the zero emissions heavy duty vehicles, on-road, off-road, rail, marine and aerospace. But we are sector agnostic, and we're very much hoping to support the manufacturing capabilities and supply chain development in that way. Like we were saying, sometimes it's about figuring out how can our traditional expertise be translated into other sectors, and that's really the key to exploiting all the opportunities that we have in front of us. Jill, I don't know if there's anything you want to add to that.
Yeah, I would agree with that. I think obviously in the sort of the FEMM Hub, we're focused on the technical aspects of the low volume, high value machines, but the idea is that the technologies and the solutions that we develop will be able to get diffused into other applications, into other sectors, and it is really all about that collaboration, which is why FEMM Hub is working quite closely with NMIS and DER to see how we can exploit the work that's coming out as much as possible.
And that goes back as well to the point that Jill made about the second life. If we're looking at a machine that's maybe got a primary life in a certain sector, it's actually in our interests, and it's actually a really good challenge to understand what is that secondary application. It's likely it'll be in a different sector, and that's why it's so crucial to have that design for manufacture at the start, where we really sit down and say, right, what is this machine going to look like? What is the lifespan of that machine? What materials do we have in there? What uses can we see? So that's again that cross-sector approach.
And I think as well, for some applications like aerospace, for example, obviously the efficiency and the safety of the machines are really paramount. So it might be for those particular applications, you can't focus on the secondary life of it. You just have to focus on primary life and then do the best that you can with it at the end of its life. But I think in other sectors it might be a little bit more flexible, and I guess it's approaching the problem in a way that we're flexible enough to change between those two opportunities, and actually it's not a one size fits all. It's actually finding the best solution for the sector or the application that we're working in, while trying to be as cross collaborative as possible. It's getting that balance.
Absolutely. I don't think we have any more questions at the moment. Is there anything else, Jill or Dan, from yourselves before we hand back over to our marketing team?
No, I think I would just encourage anyone, if there was anything within the slides and the presentations today that was of interest, please feel free to get in touch. The marketing team have put the NMIS inquiries generic email address there, but if you just Google any of our names, you'll find us on LinkedIn, and you can get in touch there. So please, do reach out, and we're happy to answer, even if it's specific technical questions or if it's more general sort of how do we get involved questions. We're happy to answer any of that.
I'd echo that as well from a DER perspective. Yeah, that was very light touch today, just with a view of time. So there's plenty more information that we can share, and get in touch. There's a specifically, we have a guide on the investment that UKRI has made recently. So if you're interested in any of the equipment investments around the UK, I can supply that. There's also a DER-IC website. If you Google DER-IC, and then, like Jill said, yeah, contactable on LinkedIn as well. So yeah, thanks very much for having me as part of this session today. So yeah, thanks very much.
Yeah, thank you all for your time as well. We appreciate your participation and look forward to continuing the discussion. With that, I'll hand back over to our marketing team just to close up for today.
That's great. Thanks very much, Gladys. Just to reiterate, thanks again for joining us today, and we hope you enjoyed the webinar. And I'd like to just also thank our presenters, Gladys, Jill and Dan, for today's session. You'll be able to find any future NMIS Insight webinars on our website at nmis.scot. Thanks very much again for joining us, and I'll just bring the webinar to a close. Thank you.